How's it going, 3D printers? Andrew Sink here, and in this video, we're going to be taking a look at a unique 3D printer that's designed for a very niche market. The company that designed this printer reached out to me and asked if I'd be willing to try out the machine and share my thoughts. So in this video, that's exactly what we're going to be doing. The Rose Go was originally a Kickstarter campaign that was successfully funded with over $57,000. This was enough to kick the machine into production, so you can now buy it off their website, and it's currently advertised at $370, with orders being shipped in January or February. The spec sheet of the Rose Go paints a picture of a machine that's designed very specifically for creating small parts at high resolution. The build volume is pretty modest, 125 by 110 by 135 millimeters, but the resolution goes down natively all the way to 0.02 millimeters. This is a really fine layer height, and we're going to see in a little bit just how much of an impact this can have on part quality. The stepper motors are also silent TMC 2208s, the machine has auto bed leveling and a filament runout sensor. The stepper motors are also advertised as having a 0.9 degree turning radius, which makes them significantly higher resolution than the standard 1.8 degree. The entire Z-stage is a single piece of machined aluminum, which makes it really rigid when it's moving up and down. Before we dive into the unboxing and printing, I'll show you an example of a 0.08mm and a 0.02mm print. You can see the impact that those fine layers have on the overall quality of the print, with the 0.02mm model looking almost like it was painted and then sanded. This printer was designed to be a good fit for anybody looking to print very small parts, very fine, who aren't particularly worried about long build times. The printer ships in retail-ready packaging, so it includes a little bit of information on some of the features of the machine as well as some of the intended uses. There are a couple of misspellings and a few little red flags that you'll notice on the side of the box, as well as this guy, who just looks so angry for some reason. I don't get it. Right off the bat, opening the printer reveals the packaging, greeting you and giving you instructions on how to unbox it, which is one of my absolute favorite things in the world. I just love it when you see this level of detail. It lets you know that you're in for a pretty smooth ride. The user manual that comes with the Rose Go is a really nice addition. It's made on high quality paper and it's got a nice feel to it, but more importantly, it covers a lot of things that are very useful for a first-time 3D printer owner. So in addition to the standard setup and assembly process of the machine, the user manual also dives into some details, like the impact of layer resolution on a finished part, as well as the differences in levels of infill for increasing the density of your 3D printed part. This is a really nice guide, and it's definitely a step above what you would expect from a typical inexpensive imported 3D printer. The included USB stick also has a digital version of this user guide as a 167 megabyte PDF. It's really high quality and definitely worth a read if you're going to be playing around with this printer. The included power supply is an external brick. This is good because it keeps the weight of the printer down, but the downside is if you lose it, you're going to have a hard time getting the printer up and running. The Rose Go includes some pretty basic accessories, and I thought it was a nice touch that they included a completed print that was made on the machine at 0.08mm, and you can see the level of detail in the print. There's also a USB stick that has a couple of pre-sliced models, as well as the digital version of the user guide. In addition to a piece of transparency paper that's used for leveling the Z height, the Rose Go includes two separate build platforms. One is a PEI sheet and the other is a textured build surface. They both have their pros and cons, but for this video, I'm going to be using the textured build platform. The packing job's pretty good on this printer, and they take advantage of the space between the build tray and the extruder to put a 500-gram spool of gray PLA filament. Once all the packaging has been removed, you can use the included quick start guide to get the printer up and running quickly. The manual setup doesn't really take a lot of time. Just snap the spool holder on and then attach the PTFE tubing to the back of the extruder leading up to the hot end. The whole process took me about 15 to 20 minutes, so I feel pretty confident in saying most people could get this done in a similar amount of time. The Rose Go has an inductive probe sensor, so the leveling is an automatic process. It will automatically probe different points on the bed, and then you set the nozzle offset using a piece of transparency paper. Loading the filament is going to be a very familiar task for anybody who's used an Ultimaker style printer before. The Bowden setup has the extruder gear mounted on the back of the printer, and the filament passes through a runout sensor before being loaded in. Clicking the flame button activates the preheat sequence, and you run into another interesting translation quirk here when you're presented with the options for PLA, ABS, and then a third non-English option. This is probably my biggest criticism of the entire machine, and that's that there's no English option for the GUI. If you've been 3D printing for a while, it's not a big deal, you can contextually figure out what's going on, but for a first-time user, I can definitely see this as being a pretty big stumbling block. I'm using the material that came with the machine, so once the material had been advanced all the way to the hot end, I selected PLA and it started extruding the material and let me know the printer was ready to run. I'm using the USB stick that came with the printer to run some test prints, and it has a pre-sliced file of a Moai statue at 0.08 millimeters. So that was the first thing I printed, and I can kind of contextually guess yes and no from this menu, so I selected yes, and that started the print. While that's printing, we can take a look at the material that was bundled with the printer. This is the Galaxy Purple PLA, which is very similar to the Prusa Galaxy Purple, but this is a Zero brand material, and the printer comes with 5 separate spools, 2 Galaxy Purple, 2 white, and then 1 in gray. I'm using the gray for the test print because it photographs pretty easily and it tends to show a lot of detail. The default models are solid for the first 50 layers or so it takes a long time to print these out. So while this is printing, let's take a look at the G-code that was included. It was sliced for a PLA material, but it has a heated build plate enabled. Oddly enough, this printer doesn't have a heated build plate, so when it starts up, it calls for the hot end to heat up, but not the build plate. We can also see that this file was generated sometime around mid-May, and we can get a little bit more information from running through the G-code and checking out the layer heights. The first layer prints out at 0.16 millimeters, which makes sense because you want a fairly thick first layer for optimal adhesion. After that, the printer switches over to 0.02 millimeter layer heights because we're looking at the 0.02 millimeter pre-sliced file. Luckily, the file was saved as an ASCII STL and not a binary one, so we can get a little bit of this information. We can see here that the file was sliced by somebody named Daniel. So, Daniel, if you're watching this, thanks for including the bundled G-code with the printer. Rose Go uses a proprietary skinned version of Cura, and you can look at it here and it looks like a skinned version of Cura 4. We have some ability to alter parts of the file, so we have 4 preset defaults: fast, normal, high quality, and race mode. Oddly enough, race mode is the thinnest layer height, which would take the longest, so I'm not sure if this might just be a translation thing. But we do have a little bit of customizability. We can change a couple of parameters, but generally speaking, we're pretty much locked into what is provided. The slice view is useful if we want to scroll through the model and look for any problem areas before printing. This gives us a pretty comprehensive toolpath view, and we can select the different types of lines that we want to visualize. At the top right of the program, you'll notice that we have diameter, flow, printing temperature, initial layer, and final layer temperature as adjustable parameters that we can play with depending on the material that we're using. The default profile is for PLA, so all of these have been preset, but if you're using your own material like a TPU, this is where you would make those adjustments. At 0.08 millimeters, the Moai statue included on the G-code prints out in just about 4.5 to 5 hours. Unfortunately, the motherboard fan of my printer arrived DOA, with the bearing rattling around leading to the volume that you're hearing here. Luckily, I had an extra fan, and the disassembly and replacement was a quick process. Once finished, part removal is really easy. Just pull the bed off and flex it, the part pops right off. Here's the 0.08 millimeter, and we'll take a closer look at this in a second, but you can see a large amount of detail was captured. We can compare this to the 0.02 millimeter model. The 0.08 looks really good, but the 0.02 looks almost completely smooth. Unfortunately, this comes at a time cost, so printing that same model at 0.02 millimeters takes a little under 16 hours. The part looks like it's been primed and sanded, so if your application calls for a smooth surface finish, this could be a very fast way to get there without as much manual effort. You can find links with more information about this printer in the description of this video, and feel free to leave me a comment and let me know what would you do with this level of accuracy on an FDM 3D printer. As always, thanks for watching and have fun printing.